Hey everyone, this is Bhargav Suthar, and today we will learn how to find an upper bound and a lower bound in a given Hasse diagram. Okay, so this is very important topic for the course of discrete mathematics. Now see, first understand what is an upper bound. So let A lesser or equals to B opposite. Now consider a subset, this B of A. Now an element, whatever, just take one element, A belongs to A, is called an upper bound of the second set B, if this B is less than or equals to A for all B belongs to B. Now let us discuss what is a lower bound. See, these are the definitions are very tedious. We will understand it by using examples. Fine. So let A less than or equals to B opposite. Now consider a subset B of A. An element A belongs to A is called a lower bound of B if A is less than or equals to B for all B belongs to B. There is no difference, just the inequality are changing. Fine. So these are the definitions. Now we will proceed for the examples. Now let us take example. Okay, so see, this is the Hasse diagram that is given. Now consider this B1 equals to E and C. So we have just specific said that is B1, that is E and C. Now we want to find the lower bound as well as upper bound of this given set. Now first we will find the upper bound. Fine. Now see, for upper bounds, just remember this thing. For upper bound, there has to be a relation from this given set to the upper points. Okay, so just consider C, E and C. Okay, so what are the upper points? Just by looking at this Hasse diagram, so H, F and G, they are the in upper position to this given set. Okay, so H, F and G, they are the upper points. Now we will decide whether they are upper bounds or not. So just consider H. Okay, now see, there has to be a relation from this set to the upper points, so that means specifically to H. Fine. Now can we go from E to H? So that means can we go from E to H? What does that mean? Is there a relation from E to H? So just simple manner, can we go from E to H? Yes. Now can we go from C to H? So just see, remember this, it is a Hasse diagram and all the relations are in the upward direction. So that means this can we go from C to H? Yes. How? Just first go from C to E and then E to H. So H is an upper bound. Fine. Now consider F. Now can we go from C to F? Yes, we can go from C to F. Now can we go from E to F? So just first, just consider first go to E to H. Then for H to F we need to go in the downward direction, but that is not possible as it is a Hasse diagram. Fine. So F cannot be an upper bound. Just consider G. Now can we go from C to G? Yes. First C to F, then F to G. So G is fixed. Now can we go from E to G? Now E to G, that means first we can go from E to H, then H to F. For H to F, we need to go in the downward direction, but that is not possible. So G cannot be an upper bound. Now consider this elements of E and C. So elements of B1, this given set itself. Now can we go from C to C? Yes. Why? Because it is a poset or it is a Hasse diagram. So reflexivity is there. So C to C we can go. Now can we go from E to C? For E to C we need to go in the downward direction, but that is not possible. Now just consider E. Now can we go from C to E? Yes, it is obvious. And can we go from E to E? We can go from E to E. So E can be a upper bound. So what are the upper bounds? Yes, E is the upper bound and H is the upper bound. Now for lower bounds, just remember this. For lower bounds, there has to be a relation from this lower points to this given set. So here the given set is E and C. Now what are the lower points? Just by looking at this graph. So as you can see that this A and B, they are the lower points. Fine. Now for lower bounds, there has to be a relation from the lower points to all the elements of the given set. Now can we go from A to C? Yes. Now can we go from A to E? Yes. So first go to A to C, then C to E. So yes, A is a lower bound. Now then just B. Now can we go from B to C? Yes. And can we go from B to E? Yes. So it is also a lower bound. Now consider the elements of the set itself. Now can we go from C to E? Yes. And can we go from C to C itself? So yes. So what does that mean? What are the lower bounds? Just A, B, C, they are the lower bounds. Now let us discuss another set, that is C, F and D. Okay. So for C, F and D, what are the upper points? So E, H and G, they are the upper points. Fine. Now can we go from, just fix E. Now can we go from C to E? Yes. Can we go from F to E? No, because for that we need to go in the downward direction. So E is cancelled. Now for H. Now can we go from C to H? Yes, from first C to E, then E to H. Fine. Now can we go from F to H? Yes. And can we go from D to H? Yes. So H is an upper bound. Now next, just consider G. So can we go from C to G? Yes. Can we go from F to G? Yes. And can we go from D to G? Yes. First C to F and then F to G. So G is also an upper bound. Now consider the elements of the given set itself. So C, F and D. So it is very clear this F has to be an upper bound. How? We can go from C to F, we can go from D to F, and we can go from F to F. So what are the upper bounds? So H, G and F, they are the upper bounds. Now for lower bounds, for C, F and D. So for lower bound, there has to be a relation from the lower points to the given set. Fine. So what are the lower points? You can see that this A and B are the lower points first. Now can we go from A to C? Yes. Can we go from A to F? Yes. Now can we go from A to D? No. We can first go from A to F, then for F to D we need to go into the downward direction, but that is not possible. So A is not a lower bound. Now for B, again the same scenario, we cannot go from B to D, so that is also not a lower bound. Now just consider the points of this set itself, C, F and D. Now we cannot go from C to D, so C cannot be in upper lower bound. Now we cannot go from D to C, so that is also not a lower bound, and obviously F cannot be a lower bound. So yes, you are right, this it is the empty set, so that means this set does not have a lower bound. Now consider the second example. So this is the Hasse diagram. Fine. Now consider the set E and G. Where is E? This is E and this is G. So we need to find the upper bound first. So again, for upper bound there has to be a relation from the given set to the upper points. So what are the upper points? Just by looking at this. So F, A, I and C, they can be the upper points. Now just discuss one by one. Now F can be an upper bound. Yes, we can go from E to F, we can go from G to F. Now for A, we can go from E to A, we can go from G to A. Yes. Then I, we can go from E to I, we can go from G to I. How? G to E, then E to I. And C, we can go from E to, we cannot go from E to C, but G to C we can go, but C cannot be an upper bound. Now consider the elements of E and G. Now can we go from G to E? Yes. And can we go from E to E? Yes. So what are the upper points? So what are the upper bounds? That means E, F, A and I. So these many will be the upper bounds. Now for lower bounds. So again, for lower bounds, there has to be a relation from the lower points to the given set. So E and G. So what are the lower bounds? So that means H and B. So just consider, can we go from H to E? Yes. And can we go from H to G? No. So H cannot be a lower bound. Now can we go from B to E? B to E, yes. And can we go from B to G? Yes. So B can be a lower bound. And elements of the set itself, G is the lower bound. So that means this B and G, it is a lower bound. Now consider another set B2, that is H, E, G and C. So H, E, G and C. These 4 points are there. Now we need to find the upper bound of this set. So again, there has to be a relation from this set to the upper points. So what are the upper points? So D, F, A, I and C, they are the upper points. Now we can go from H to D, then we cannot go from G to D. So D cannot be there. Then F, for F, what is the false one? We cannot go from C to F. So F cannot be there. Now then A, we can go from H to A, E to A, then G to A and C to A. So A can be an upper bound. And last I. So I is also an upper bound. Fine. Now for lower bounds, there has to be a relation from the lower points to the given set. Now as you can see that it is clear that B will be the lower bound, because here only one point is there, so it will be the lower bound. Now consider the third set. This B3 equals to A. So this A. Now we want to find the upper bound of this. As you can see that, what will the upper bound? It is very obvious. Why? Because we don't have any upper points. Okay, so that means this A itself, it is an upper bound. Fine. Now for lower bound, you can see that this all the points are lower points to A. Fine. So there has to be a relation from this lower points to the given set, that is here A. But it is very obvious that we can go from each and every points to A. So that means this all points will be the lower bounds. Fine. Now consider another example. This is the Haze diagram we have. Now consider B1, that is B and D. Now where is B and D? So we will do it very fast. Okay. Now B and D. So for the upper bound, B and D, what are the upper points? So as you can see that D is the only upper point. Fine. So D will be the upper bound. Now for lower points, for lower bound there has to be a relation from lower points to the given set. Fine. So what are the lower points first? E, G, A, F. Okay, so can we go from G to B and G to D? Yes, so G will be the lower bound. Now for E, we can go from G to B and we can go from G to D, so E will be a lower bound. We can go from A to B and A to D, so A will be a lower bound. Now we can go from F to D, but we cannot go from F to B, so it won't be a lower bound. And also B itself, it is a lower bound. So A, G, E and B will be the lower bound. Now consider another set, that is B2, that is A and C. So A and C. So what will be the upper bounds? Okay, for upper bound there has to be a relation from the given set to the upper points. Now can we go from A to B? Yes. Can we go from C to B? No. So B is cancelled. Now D. We can go from A to D, C to D. So D will be the upper bound. Now for the set A and C itself, C will be the upper bound. So that means the C and D will be the upper bound. Now for lower bounds, we can go from E to A, we can go from E to C. So that means E and A. So A and E will be the lower bounds. And the last set, that is this B and C. B and C. So for B and C, what are the upper points? It is only one. So that means this D. We can go from B to D. We can go from C to D. So it is the upper bound. And next, what are the lower points? So G, A, E and F, they are the lower points. Now we can go from G to B, but we cannot go from G to C. So G won't be there. Now in same manner, F cannot be a lower bound. So what are the left? A and E. Now we can go from E to B, E to C, and also A to B and A to C. So that means this A and E will be the lower bounds. Fine. Thank you.